Hello students, this video is for class 7 chapter 16 electric current and simple circuits. This is basically a chapter which comes under physics as far as the branch is concerned. So starting it, first of all, the first definition that we have is your electric current. So we have studied in the previous units, that is your matter and chemical formulae, that there are two types of charges, right? One is your positive charge and the other one is your negative charge. So basically, whenever there is a transfer of charge from one end of a material to the other end, we say there is a current. So current is nothing, basically the movement of charges. Now, as far as the movement is concerned, it is only the negative charges. Then now you can understand it is basically the electrons which move, right? So as far as electric current is concerned, it is considered as a movement of electrons from one end of a material to the another end, right? And being a physical quantity, its SI unit is considered as ampere. Now comes what is the electric circuit. So as we have studied in the previous classes also, like basically circuit means a path for the flow of electric current, right? And there are certain components which are basic, which are mandatory required for the current to flow. And out of these, if we have to study, the first is your basically a source of electric current. So as far as source is concerned, we have studied it might be a cell or a battery. Then we have basically a conducting material. Basically we use wires, right? Then we have a switch, basically to have a manual control over the flow of current in the circuit, right? And finally we have a load, basically, which might be any sort of appliance which consumes electrical energy, right? So here we can see there are two diagrams. Basically, one is for open circuit and the other one is for closed circuit. So open circuit basically means when the circuit is broken and the path is not continuous for the current to flow, right? And closed circuit means basically the continuous path. So current always flows basically in a closed circuit, it never flows in a open circuit. Now considering, like, we'll discuss in brief about the each and individual components that we have studied as part of the basic circuit, right? First comes your cell or battery. Cell or battery basically means a source, right, which will be giving out the current, right? So as far as cell is concerned, it's like a portable source, right? And it might, you would have seen it, right? Like if you have a remote, right? In the remote we use cells, right? So basically that type of cell only we are discussing. And you might have seen, right, there are basically two terminals, one is positive and the other is negative. So current always flows from the positive end of the terminal to the negative terminal through the external circuit, right? And there are multiple devices where we have seen, right, like you would have seen in calculator, in watches, right? And in clocks also we use cells. Now what is the basic difference between a cell and a battery? So as far as the difference is concerned, it is basically the amount of current that they can generate. So cell is basically we use when the requirement of current is very small. And you can say a collection of cells to give a more powerful, or you can say a bigger quantity of current, we use battery, right? It is something similar which you would have seen in your cars, or you can say in your home, like next to your inverter. Next comes your bulb. Bulb is basically here in this circuit we are using as a part of load that we need, just to make sure that circuit is closed or open. Because if it is glowing, we can say the circuit is closed. If it is not glowing, we can say the circuit is off, circuit is open, right? So basically in the center of the bulb we have a filament, a thread, wire like structure, right? And it is made up of tungsten. The reason of for making tungsten is like it has a very high melting point, right? Right, if this filament, or this, you can say, the small wire which is present inside the bulb is broken, it might not glow. The reason being the circuit will become open. Then we have a switch or key. The It's one or the same thing, right? It's ideally it's in simple words, it's similar to the switches that you have in your homes also, right? So basically turning on the switch means, right, you are closing the circuit and the current will flow. And if you are turning off the switch, basically means the circuit will become open and the current will not flow, right? And same thing is done with key, right? It's when it's on and when it's off. Okay, now the next means, like, basically for connecting all the three other things, like for battery and for bulb and for switch and key, connecting all these things, we need a conducting material or medium between all these devices, right? So we use connecting wires, and we can use wires made up of multiple type of different type of materials, right? But we prefer copper. The reason being the copper being cheap, and also easily available. It is extensively used. But as far as the metals are concerned, silver is considered as the best metal for the wiring purpose, but being costly, we cannot use it, right? Now comes the water ammeter and voltmeter. So basically, they are the devices which are used for measuring the value of current and for measuring the value of potential difference. In simple words, if you have to measure the voltage across the 2 points or any two given points of a circuit, we use voltmeter. And if we have to measure the amount of current that is flowing inside the circuit, we use ammeter. Now moving on, now what exactly is happening, like we have studied about the energy, one being one of the physical quantity of physics, right? So energy, as far as concerned, basically means the capacity to do work, and energy can exist in different type of forms. We know that it might be in the form of mechanical, electrical, sound, or heat. So basically electrical energy, we are convert when we are using in a house also, you can say, right? We are using it for different type of works, right? For example, you might connect your system, woofer or music system, to the light, and there exactly the conversion is happening from electrical to music and sound energy, right? Like when you are turning on a light or a bulb in your house, so you're converting electrical energy to light energy. And when you are turning on a fan, basically that time the conversion occurs from electrical to mechanical. Now basically we have studied this also, like electric current is nothing but the rate of flow of charge. In simple words, we can say that is a charge flowing per unit time. Now we have been given here over certain you can say symbols that are basically used instead of making the exact diagram. The next topic that we have is basically the heating effect of current. And as far as the heating effect of current is concerned, it is a simple topic. We can simply say, right, if current is flowing across a wire, or you can say a conducting wire, then it gets heated up. Basically due to the resistance being offered, right? Resistance is nothing but you can say the hindrance that occurs that comes in the path of electric current when it is flowing across a wire, right? And this resistance is something which determines that how much a wire will get heated up. So this was given by a scientist named as James Prescott Joule, and that is why this heating effect is also called as Joule's law of heating effect, right? Okay, now this heating effect basically is being used in our daily devices also. Like you would have seen electric toaster in your house is electric heater, then electric geyser, immersion rods, or you can say simply iron for ironing your clothes. These are something like you would have seen where we are actually converting for the electrical energy into heat energy, right? So there exactly the heating effect of electricity is being used. Now how much the heat will be produced or generated, or it depends on certain factors. There are three factors. First is your cross sectional area, then second is your time, and the third is your current. So cross section here area here basically means the width of the wire. If a wire is thinner, then you can say it will be having more heating effect, and if it is basically a very broad wire, very thick wire, you can say the heating effect will be less. And as far as time is concerned, it is directly proportional. If for current is being allowed to flow for a longer duration, the wire will get more heated up. And the current basically here means the magnitude, or you can say the quantity of current that is being flowing across a wire. Now the next topic that we have is basically your fuse. As far as fuse is concerned, it is simply a protecting device. You would have seen, if you ask your family member, as we have seen in the school also, it is basically something which is given in the figure number 16.4 over here, right? It has two metallic end caps and one thin wire in between. So basically what happens, the principle is simple, right? It's a simple protection device, and it works on the principle of heating effect. So what happens exactly is, like if there is a maximum prescribed value for the various devices, but however due to some certain reasons, if the value of current exceeds that limit, right, so this wire will also get heated up, and this will get melted up, and thereby protecting the current to get inside your various devices, right? So basically fuse is something, you can say, a simple wire which is made up of material having a very low melting point. Now we have cartridge type of fuse also. Like you would have seen, like if you go to your villages or in a very old building, right, there you will see this cartridge type. And nowadays, which is more in use, is basically MCB. So MCB, miniature circuit breaker, is used along with your fuse for the protection of devices. So what it does actually is, like, so current, when it is coming from the transmission poles to your house, it first goes inside the MCB, and if the value of current that is being entering your house is more, right, it rips down. This is a common word that you would have heard your parents being saying. right? Now there are certain words, certain definition that comes is that is your overloading and short circuiting. So what is overloading? You might have heard of this thing like during the summer season, peak summer season, like if you're turning on all the fans and the lights, then you would have heard from your parents or grandparents like don't use it too much. There is a condition of overload. So overload basically means when you are drawing more amount of current, right? When there is a load is very heavy, you can say in simple words, multiple number of appliances are being used at once. So what happens cause of that is like if more amount of current being drawn, then the wire might get too much or heated up, and cause of which the plastic coating which is there on the wire, it will get melted, and it might result in a short circuiting. So the next topic that we have is your magnetic effect of electric current. So as far as the heating effect is concerned, it was simple. Like if a wire is carrying current, it will get heated up. That is called heating effect. And magnetic effect is similar to that. It's like if a current is being flowing across a wire, then it will produce a magnetic field. So what Hens Oersted did actually, basically he kept a compass next to an you can say electrical circuit, and when he was turning on and off, he was finding out the deflection being happening in the magnetic compass. And now you know that magnets repel or attract depending upon in the vicinity of other magnet. So that is basically happening because of the interaction of the magnetic field, right? So here also there was a magnetic field being generated by the wire, and that's how he was able to say there is a some sort of magnetic field generation cause of the wire. Now, moving on to the next topic, basically, there certain points are being stated by the Oersted, and he said like the deflection of the compass basically depends upon the direction of current in the circuit. For example, current might flow in a clockwise direction or an anti-clockwise direction, which may result in the deflection in a particular direction. And the amount of deflection means like if it is a small deflection or a or very high deflection, that depends upon the quantity of current being flowing across it. Now comes the next topic, that is that is basically your electromagnet. And as far as electromagnet is concerned, the name itself suggests, so it is a type of temporary magnet. Temporary magnet means like it retains its magnetism for a shorter period of time, like and how it is happening is like till the time the value of current is there, we can say that we have magnetic properties, and after that the time or the moment that we stop the flow of current, we say that magnetism is being lost. So what happens exactly in this diagram we have seen, right? In the figure number 16.6, we have taken a long iron nail, and we have connected, we have taken a wire, we have wound it in a form of coil across the in the form of like coil, and we have connected the two ends to a battery. And when we are connecting it to a battery, and if certain iron nails are being brought near to it, they will get stuck to it, showing that it has been converted into magnet. And the moment we remove the terminals or you can say the ends of wire from the battery, we'll see that the magnetic properties are being lost. So such type of magnets which show magnetic properties as far as till the time the current is being flowing across, then we say that they are called as electromagnet. Now there is one more word that is called as solenoid. Solenoid, as far as concerned, it is basically means a long insulated wire which is wound in the form of which is wound around a hollow metallic core. So it is something similar to the spring that you would have seen in your daily life, right? It has nothing in between, right? And as far as electromagnet strength is concerned, it depends on two factors. First is the number of turns, and secondly it depends upon the amount of current which is being flowing. Now as far as the use is concerned, the important use that we have in our syllabus is the electric bell. So as you can see clearly in the diagram, we have a battery, we have a soft iron armature, then we have a switch, hammer, gong, and a horseshoe magnet, which is a horseshoe type of structure, and which is basically wounded with the wire. So what happens the moment we press the key, so this circuit will get completed, armature will get attracted towards the horseshoe magnet, and thereby resulting in the hammer hitting the gong, and this will result in opening the circuit. Now again it will lose its magnetic properties, armature will go back, and it will again come and hit back, right? So this continuously hitting and hitting will go on till the time switch is kept pressed. And that is why when you would have heard in your school also, there is some sound like tar 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 tar, if you would have noticed, and that is cause of the continuously hitting of the hammer to the gong. So that's it from this chapter, guys. Thank you.